Okay, welcome. So now that we've talked about some history of the atom, let's talk about the parts of the atom, where they're found, charges, masses, etc. So first we have is the proton. So the proton, I like these pictures, large with a positive charge, and this is sort of like an atom. So in here we have the nucleus, discovered by Rutherford, and then we have the electrons going around. Protons, the symbol is P plus. Sometimes it's superscript P, the superscript plus sign. You will find these on the reference table as well. Charge, positive 1. Each proton has a charge of plus 1. So if we had 5 protons, the charge would be plus 5. Where are the protons located? Within the nucleus. And the mass of a proton is 1 AMU, or 1.66 times 10 to the negative 24 grams. Only this will be required to be known on the reagents. You'll also see that it's an AMU is sometimes known as just a U. So you might see 1 U, and that would be the mass of a proton. So another part of the atom we have is called the neutron. Notice again that the neutron is located right next to the proton in the nucleus, large and no charge. So you'll see little n, and it has to be lowercase n, not capital N. Capital N would be a nitrogen, and n to the 0, meaning no charge. So you could say it's got a no charge, it's neutral, or a charge of 0. Also located within the nucleus. And again, the mass is 1 AMU, or that 1.66 times 10 to the negative 24 grams. I'm just putting this here for scale. Very small. So let's see, 1.66 times 10 to the negative 24 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 of a gram. So that's really small. But what's even smaller than a proton or a neutron is the electron. So electrons, you'll notice, are on the outside. They are small with a negative charge. E minus, lowercase e, minus sign, negative 1. So again, if we had 6 electrons, that would be a minus 6 charge. They are located around the nucleus of the atom. We're going to speak much more specifically coming up later, but for right now, they are outside the nucleus. And according to the reagents, the mass of an electron is essentially a 0, or 0. But this is the true mass, 1 over 1836 of an AMU, or 9.07 times 10 to the minus 28th of a gram. Super duper small electrons. Again, what is an AMU? That's called atomic mass units. So the measurement of these subatomic particles, or the sum of those subatomic particles in what we call atomic mass, is measured in atomic mass units. So it's balanced out from the most common carbon isotope, which is carbon 12. It is 1/12 of 12, which is 1/12 of, so 1. And it's found on reference table D as simply U. So let's see if I can show you. Here we are on the reference tables. Table D, we have atomic mass unit is right there. And I believe on the honors reference table, which again, some of you might not have, they used to have, oh no, that's the charge of an electron they had. Oh no, here it is. Let me just erase this right here. 1 AMU, it's right here. 1.66 times 10 to the negative 24 gram. Mu, the Greek letter mu. So again, if you do not have the honors reference tables, that's no problem. You will not be asked the mass of anything in grams. It will be in AMUs. AMU would be accepted on the reagents, or U. Whoops. Okay, great. I think that's where I'd like to stop. All right, thanks for watching. So atomic number has to do with some of the particles we were talking about earlier. In fact, it has to do with protons. Atomic number is another way of saying the number of protons. So you would go to the lower left corner of an element box on your reference table to find out. So let's do that. So on the reference table, which unfortunately is going to be sideways for us, I apologize. So right here, atomic number is right there. So the atomic number goes 1, 2, 3, 4, 5, etc., etc. So lower left corner of the periodic table. Okay, great. So if you had hydrogen, let's look it up. By the way, if you don't know what the names are, you just go here. Oh, look, you don't even need periodic table. So hydrogen, and again, I apologize, this is sideways. I can probably rotate it, but I don't know right now, so sorry. Hydrogen has atomic number of 1, which would mean 1 proton. Sodium is here. Atomic number 11, which means 11 protons. Oh, yeah. Gold. Shoot. What is gold? Gold is AU. 79, I think? Yeah, gold. Sorry. I'm sorry. So if it's 79 atomic number, it would be 79 protons. Mass number is when you add protons plus neutrons, because if you remember, those are the only two subatomic particles with any mass, 1 AMU for each. So 1 atom is the mass of a single atom. Oh, sorry, is the mass number. So if you go back to periodic table, you'll see that all these masses, I'll change the color, they have decimal places. If you wanted to just round that to a whole number, that would be called mass number. Because you can't have like 2.8 protons. It's either going to be 2 protons or 3 protons. So what would be the way to calculate your neutrons? Well, if you know mass number from periodic table, and you can figure out protons from periodic table, then all we'll need to do is subtract the number of protons from your neutrons. Number of protons from your mass number. So mass number minus atomic number. And if you saw on periodic table, it was arranged like this, I can kind of see a subtraction. So 12 mass number minus 6 protons would mean 6 neutrons. So gold, this is the mass number. This is the number of protons. This is the number of neutrons. And to once again show you gold, gold is number 79. Again, I know it's sideways. I'm sorry. So you can see it says 196.967. 196.967 rounds to 197. Lead is right here. 207.2. So 207 minus 82. So that would be what? 5 and 125? Yeah, I can subtract. Now uranium, the heaviest of all the naturally occurring radioactive isotopes, radioactive elements. 238 minus 92. 6. Carry the 1. 13. 146. Very good. Yay. I think, yeah, that's where I'm going to stop. Thanks.